Welcome to this lesson on graphing equations. Today we're going to talk about how to graph an equation, how to find the different pieces of that equation, and then how to write the domain and range from a graph. Alright, so first of all, if they give you an equation, in order to graph it, you have to solve it and find your different x and y coordinates. So here I have y is equal to 2 times x. So I know that the x values that I have are -1, 0, 3, and 5. So to solve, I put in, so for x, for the first one, I put in -1, so it's 2 times -1. So I know that my solution is -2. And then for x equals 0, I do 2 times 0, and I know that my solution is 0. And then for 3, it's 2 times 3, which gives me 6. And then 2 times 5 gives me 10. So now to graph this, these would be my ordered pairs. So my first ordered pair would be -1, -2. So -1 to the left, -2, and then 0, 0. And then 3, 6, so over 3, up 6, and then 5, 10. All right, and then to graph, I would use my line tool. You want to make sure to use a straight edge when you graph so it makes a nice straight line. Do not freehand it. And then you're going to make sure that you put an arrow at both ends, because an arrow shows that that graph goes on forever. And when you're graphing something in all 4 quadrants, unless otherwise specified, your graph will go on forever in both directions. So in this case, if I wanted to find my slope, I could start at 0, 0 and go up to the next spot. So I know I would go up 6 and to the right 3. So my slope would be 6 over 3, which would actually be, divide them both by 3 and you get 2 over 1. So I have a slope of 2. And then my y-intercept. So your y-intercept is where your graph crosses the y-axis. So at what x and what y. So in this case, my y-intercept, my x will always be 0, and in this case, it crosses at where y is 0. So the y-intercept for this one is actually 0, 0. Right, so again, we can try this one. So we do -1 minus 2. So -1 minus 2 is going to give me a -3. So -1, -3. 0 minus 2 gives me a -2. 3 minus 2 gives me 1, and 5 minus 2 gives me 3. So now I know my ordered pairs are then 0, -2, 3, 1, and 5, 3. All right, and then again, you're going to use your straight edge. And plot your points, graph your points. Right, that dot wasn't quite where it needed to be, but now we have all of our points graphed and we have our lines created. So now here, and I could also use the formula y2 minus y1, but since I have a graph, I might as well just count and make it easier on myself. So here I know that I'm going up 1, 2, 3, and then to the right 1, 2, 3, which would be 3 over 3, which is equal to 1. So I have a slope of 1. My y-intercept, so now so when my x is 0, what is my y? So when x is 0, so when I don't move right or left, when I stay on the y-axis, my y is -2. So the y-intercept is 0, -2. Right, so this is one where I would suggest that you pause and try to graph your own answers and then come back and check your work. All right, so in this case we have -2/3 times 3 plus 7. So we have 2 plus 7, so that gives me 9. All right, and then if I continue on here to save us some time, I get 7, 5, and 3. And then I know that this graph is off because I moved it a little bit. So let me move it so that way it fits again. There we go. So this is what my graph would end up looking like. So then my slope, because we're going from left to right, we're going down, so I know it's a negative slope. So I go down 1, 2, and to the right 1, 2, 3. So my slope is negative 2/3. And then my y-intercept, so when x is 0, which you can see you can also find in the table or on the graph. So when my x is 0, my y is 7, and that matches here on the graph and on my table. And I can get that from my equation by doing negative 2/3 times 0 plus 7. Well, this is going to be 0 plus 7 will give me 7. All right, so moving right along. So when you are determining the domain and range of a graph, this is where you have to write it as an inequality because you have so many possibilities because every number between here and here is a part of the graph and so it has to be included, but there's no possible way to write all those numbers, so we write it as an inequality. So first we're going to write the inequality for the domain. And the domain in this case is our x values. So let's change the fact that it's Monday, Tuesday, Wednesday, Thursday, Friday. Let's just change those to 1, 2, 3, 4, and 5. Okay, so in this case, we have a domain where the smallest number is 1 and the biggest number you can have is 5. So x can be bigger than or equal to 1, so it can be 1. It can be anything that is bigger than or equal to 1, okay, because it's here, but the biggest that it can be is 5. So what this means is that the domain can be anywhere from 1 to 5. It can't be anything smaller than 1 because you'll notice there's nothing graphed here, and it can't be anything bigger than 5 because there's nothing graphed over here. The range then, now this is a little bit harder because with the domain it worked out nice and simple where the smallest number was to the left and the biggest was to the right. Well here this is not my smallest range. This is actually my smallest y value. So my smallest y value is 200 and my biggest y value is about 650. And actually I have to use brackets, not parentheses. Oh yeah, that's a great bracket. So then here, I know that my y, so this value, can be 200, so we have to use the equal to. It can be bigger than or equal to 200, so it can be anything, it can be 200 or above, but it cannot be any bigger than 650. So it has to be anywhere between this 650 and this 200. So all these numbers in here, so actually if I show it over here, this might make more sense. So every number between 200 and 650 is a part of my range, even all the decimals and fractions, everything. Now here, this is where it's a little bit more difficult because you'll notice we have the arrows. So when we have the arrows in both directions, that tells us that it goes on forever. So in this case, my arrow is going to go all the way left, possibly that it can, all the way right, all the way up, and all the way down. So that's when we use infinity. So the domain is going to be all real numbers. And so is the range. So instead of writing it twice, or if I want to stay with this format, which we should really practice that, so we're going to go ahead and do that. So the domain is negative infinity, so y can be greater than or equal to, x can be greater than or equal to negative infinity and can be smaller than or equal to infinity. Same thing with the range. It can be greater than or equal to negative infinity, and it can be less than or equal to positive infinity. Okay, so what this means is every single number in each direction is going to be on this graph at some point. Now, I know usually we look at it and go, oh, but this is a point on the graph, and this is a point on the graph, but so is everything on this line. So all these numbers that aren't easy numbers are still part of the graph. We just don't typically work with them because they're not easy to work with, and you'd have to estimate based on where they are on the graph as to what they're worth. So that's why we stick with using numbers that we know. This is my x is going to be 3 and my y is going to be 6. Okay, so then what you're going to do here is you're actually going to try these problems on your own. Okay, and this is where we are looking at something in specific. So you are going to give me the domain and range for both of these. Okay, and then we are actually going to practice some graphing here as well. You're going to create your own table, use the equation to solve and make your own table. I actually am going to let you choose your x values, and I'm just going to let you decide what you want to use. Just be smart with the numbers you use. All right, don't use big numbers like 20 and 30 because that's going to be too big for your graph. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.